This section is 14.3. It's called Functional Terminology, and you can find it in page 631 on your textbook. So let's back up and think about some of the type of lines that we've seen. So first I would like to highlight over here on this, this red line over here. We've got the y is equal to 2/5 x plus 1. And one way we can do this is we can just understand straight off that using your y is equal to mx plus b, you know that you have a b is equal to 1. So that's this point right here in green. And then you have 2/5 x. So it would rise 1, 2 to here and then run 5. 1, 2, 3, 4, 5. So it's going to come out to here. So my line is a little off. But that's one way to sketch the line. Another way to sketch the line is to plug in a value for x of 0 and then see what you get for y, and then conversely get your second point, put in a value of 0 for y, and get a value for x. And then our blue line is done much the same way. I have put in 0 for x and received a 6 for the y. And then if I put in a 0 for y, I get a 3 for the x. So these are all my coordinate pairs, and I've plotted them and sketched in a quick little graph of their lines, and I've labeled my lines. So these are functions, and what I'd like to do is have you look over here on the left side where it says y is equal to 2/5 times 7. So what I wanted to do is I want to say, what does x equals 7 look like? So what do? Is I bring out my line, my red equation, and I just input 7 where the x is. And then so what I end up getting is -8. So I have another coordinate pair here that would be 7, -8. So for my red line, I'd be 1, 2, 3, 4, 5, 6, 7. No, it wouldn't be -8. Oh, I messed that one up. How did I get that one wrong? 2/5, 14 fifths. Oh, I'm sorry. Yeah, I was. Let me back up here. It wouldn't be -8. That's coming off of my blue line. If I put in, I mix my lines here. My red line, if I put in a 7, I would get a 3.8 out. So that's what my y of 7 gives me an x of 7 gives me a y of 3.8. And then conversely, if I put in a 7, if x equals 7 here, then I get the -8 on the blue side for the blue line. Now the reason I chose the number is I want you to see that these are two different numbers. I put in an x in both of these equations, but the equations are different. So at an x of 7, 1, 2, 3, 4, 5, 6, 7. So that's a 7 out here. My red line is going to be a 3.8. 1, 2, 3, 4. So my red line is going to be out here somewhere at 7, 3.8. But then my blue line is going to be way down here at -8. It's going to be off the page, which is keeping in with this line that's continuing, the blue line that's continuing. So my next thing that I would like for you to understand is this down here in the corner. This is what I need you to, the new information you're going to be receiving is that I'm no longer going to call it y. I'm going to call it f of x, which means function of x. And f of x is equal to 2x plus 1, which is the red line. And then when I have two lines on one graph, I use a g of x to describe the other line. So the g of x and f of x you can both think of as a y component. However, g of x is one component or one line, whereas f of x is another. Let's look at how we say this. So for my red line, I would say f of x is pronounced f of x. So if you see this f open parentheses x close parentheses, you're supposed to say f of x, and it means function of x, which is what y is. Y is a function of x, but we're changing its meaning, or it's the way we use it. Because we're going to have multiple y's on one plot at one time, so we don't want to say y1 and y2. They're going to change it up and say it's a function of x. And then, so for my red line, if I put in that x equals 7, what that's going to look now is it's going to look like this. It's going to mean f of 7. It's going to mean function of 7. It's not f times 7. It is taking the function f of x and inputting a 7 where the x is. So this f of 7 means put in the 7 in the equation that you started out. That was the original equation, 2/5 x plus 1. Okay? And then for the blue line, we call it this g parentheses x close parentheses is pronounced g of x. And if I said, let's look what g of 7 is, well, all that means is put the 7 in the x position. So g of x, if g of x is equal to negative 2x plus 6, then a g of 7 means I put in a 7 where the x was, which is right here being multiplied by the 2. So I'm going to get negative 14 plus 6, which is equal to negative 8. It does not mean g times 7. It means the g of x with x equal to 7. But in order, we don't say all that. We make it short and say g of 7. Okay, so my first example would be, let's look at this function. F of x is equal to 0.3x minus 14. Now remember, if you're still confused, y means if y equals some function of x, you could think that y is equal to f of x. So it's meaning the same thing. I'm still saying y equals 0.3x minus 14. We're just changing the terminology. We're changing the name of how we say it. So f of x is equal to 0.3x minus 14. That's my function. Now, what I'd like to do is I would like to see what it looks like when at f of 0 in green, f of 52 in blue, and f of negative 3 in red. And then, so let's look at the green. So here is f of 0. And then, so what I'm going to do is, at this point x, I'm going to put in a 0. So this is what it looks like right here. 0.3 times 0 minus your 14 gives you negative 14. So f of 0 is equal to negative 14. So what does the f of 52 look like? Well, f of 52 means you put in a 52 here at the x point. We're putting in a 52 where x is. So it's 0.3 times 52, again, minus 14, and that's going to give you 1.6. And then the last one that they want you to see is f of -3, which I said was the red one. So you put in the function of -3. So you put in 3 times -3 because, again, I'm putting a -3 right there where the x is. And then so you get -14.9. Yes. It's a misprint out of the book, Matt. They mean 52. All right, so then for the B part, what they're asking is they're saying find x if f of x is equal to 25. So basically they're saying y is equal to 25 and then solve for x. So I say, I set up my original equation is the same as the one above. F of x is equal to 0.3x minus 14. But here I'm saying this f of x is equal to 25. So then I just solve it backwards instead of solving it to figure out what the function of x is. I figure out what x is. So x would be 130. So I put in 25 for my y value and equal it to 0.3x minus 14. Multiply everything, or subtract, add my 14, and then divide everything by 0.3. And your answer is 130. Moving on to your second example, here we're going to combine two functions at the same time. So what we're looking at is we're looking at the red function, which is f of x is equal to 5x plus 11, and then your blue function we're going to call g of x is equal to x squared minus 8. So the first thing we want to do is look at what f of 3 is and then compare it to g of 3. And then to do the same thing with f of 10 and g of 10. And then we're going to take the part of b and we're going to divide the f of 10 by the g of 10. Okay, so I'm going to go to my next slide here. Here is still our same functions. They're the same thing. G of x is on the right and f of x is on the left. So remember, for for number A, we wanted to know what it looks like with a 3. So I say f of 3 is 5 times 3 because, again, I'm putting the 3 where the x is, plus 11. You get 15 plus 11. F of 3 is 26. So let's look at what the g is. G of 3 is going to give me 3 squared minus 8, which is going to give me 1. So then f of 3 is greater than g of 3. Continuing down to part B, they want to see what f of 10 looks like. Well, it's the same way we're doing it. You plug in a 10 where your x should be, so you get 50 plus 11, so you get f of 10 is equal to 61. But on your blue side, your g of 10 is going to be 100 minus 8, which gives you 92. So now the tides have turned and the g of x is bigger at this point. And then finally they say, what does f of x divided by g of x look like? Well, that means you take what f of x was, 61, and you divide it by what g of 10 was, which was 92. So when you divide two functions by one another, if you're given the 10 here, so g of f of 10 divided by g of 10, that means to put in the number that you got for g of 10 and f of 10. So just divide 61 by 92. And that just gives you, that's a calculator problem, it gives you 0.663. The third example that I'm going to look at is we're going to take some equations and graph them on the same plot. We're going to look at their intersections graphically, that's where they cross, and we're going to look at them numerically using a substitution type of method that we've seen before. So looking at A, where they both well, what was A? Let me go back. Graph both functions on the same plot. All right, so first of all, I need to graph my A, my g of x and my h of x. So I've made g of x, I've made it red, and so I can tell from the -6 that my b is -6, so therefore my y-intercept is -6, which is the red b is right there at -6. And then I rise 3 and run 5. So I'm going to go up 1, 2, 3 and go over 5. 1, 2, 3, 4, 5. So that's how I got my second point. And then I drew my line. And then for the blue side, I did the same thing. I went to a b of 8. So right there, there's my blue b, a b of 8. And then I went down a -2, which means I rise a -2 and I run 1, which means I go down -2 and over 1, down 2 and over 1, down 2 and over 1. So I step down with that, making my line there. So I've effectively drawn my line and shown where they intersect. And when you do it this way, you want to draw it as best you can and then just look at the graph and estimate where it crosses, where they cross. And so that estimation was 5.4 and -2.8. So somewhere in this neighborhood right there. And this, when you're given the graphical intersection, there's always a little leeway because it's quite difficult to get it on the nose. Then the next thing it says is show where it intersects numerically, meaning using the math. Don't draw it, but use it using the math. So what is unique about having these two functions is that I now see that they are equal to each other. So at this point, g of x is equal to h of x. Now, you're going to think that this seems a little different, but I want you to recall that we used to take one function and then we would subtract another function and then get your third function. What you're doing is you're essentially subtracting these two. So if you if you move the h of x over, you're going to get g of x minus h of x. So we have seen this before, but we're doing it in a different way now. I am actually just subtracting g of x from h of x right here. So your g of x is your red portion. It was 3/5 x minus 6. And then I'm going to equate that to my h of x, which was -2x plus 8. Simple algebra, I'm going to move my 6 over, and I'm going to get 8 plus 6. And then I'm going to move my -2x over and get a positive 2x. So in the end, my x becomes 5.38, which is really close to my estimated 5.4. So then what I need to do is I need to take this value that I calculated for x, and put it back into the equation. So this is where you use the substitution method. You're going to put it back into the equation and run a g of x using x at 70 over 13. So the value of 5.38 you put in inside g of x. So you can see my red g of x here is 3/5 x. This used to be an x minus 6. So I'm using this equation that I had from the very top. And then it's going to generate a value of negative 2.77, which was really close to my negative 2.8 that I determined graphically. And these are in the book that you can look at and go through at your slower leisure. You only have 7 problems to do for homework.